Okay, where we left this in a previous video was that we put this model of a bathtub with a faucet that fills it, and based upon a full level and a gap. Though when we run it, it fills the bathtub in 1 minute, which really doesn't make too much sense because most bathtubs don't have faucets that will put 50 gallons a minute into the bathtub. So there's something that we need to do to the model to make it a little bit more reasonable, a bit closer to reality. So let's use another variable, and we'll call it fill rate. This is the max rate at which the faucet can fill the tub. So maybe we should really call this max fill rate. Max fill rate. And we'll define this. Well, because we probably want to change this and play with it over time, there's another aspect of variables that you can use within a model. You can develop a slider for it and say that the minimum value is 0 and the maximum value is 5, so that now there's a slider in this part of the window so that we can say that we can define what the maximum fill rate is either by moving this slider or entering the value. So let's just call it 3. And then I can use that with a link to communicate it to the faucet. And what I'm really trying to say is that this is the maximum rate at which the faucet can fill the bathtub in a 1 unit period of time. So I now need to change this formula for the faucet, and I need to define it in such a way that it's really an if then else, so that if the gap is larger than the maximum fill rate, it uses the maximum fill rate. Otherwise it uses whatever the value of the gap is to decide what the flow is going to be into the bathtub. So we'll go into the formula and we'll go down in here into logical structures, and we'll find this if then else logic structure, and it says if then else, and we'll test this if the gap is greater than the maximum fill rate, then the value that we want to use is the maximum fill rate. Otherwise, we want to use the gap. Okay. Now we also should tell this that the maximum fill rate is also in gallons, and we need to modify this so that whether this is the max fill rate, which is in gallons, or the gap is in gallons, either one of those, divided by time, which will in fact give us a gallons per minute. So if we set this at 3 and we now go ahead and run the simulation and see what happens, notice that the bathtub is filling at, let's see, we got the maximum fill rate, which is the blue, which is 3, which we defined. The bathtub starts at 0 and it's filling at the maximum rate of 3 gallons per minute, and after a period of 10 minutes it's not full. So let's go ahead and alter the settings here and set this for 20 minutes and see if the tub will fill within 20 minutes, and it does. So that in the 3 minute, in the 1 minute, each minute it adds 3 more gallons to the amount of the tub But when it finally gets to this point, the distance between how much is in the tub and what the full level is actually less than the maximum fill level. So it fills at the rate equal to the gap. And this is easier to see if you make this a little bit bigger. You can see that it tapers off in curves. We can probably see this a little bit better if we actually made the fill rate 5 and reran it to play with it this way. Well, actually that's not better, it's actually worse. 10. Oh, the problem here is that it actually fills the tub exactly based upon an increment of 5, so that there is no tapering. Let's try one more time. We'll make this 4 and we'll change the time settings to 15 and we'll see how this works out. So now you can notice that here again the gap, as the tub is filling, the gap continues to get smaller, and when it finally gets to a point where the gap is less than the maximum fill rate, the amount of water that flows into the tub during the next time period is less than the maximum fill rate. It's just enough to fill the tub, and when the tub is full it shuts off and we're done. So there's several aspects of this that you should notice, in that it's build a little, test a little, build a little, test a little. And you probably won't develop religion about that perspective until sometime that you actually are working on a model and you add a dozen pieces to it and it doesn't work. And you spend hours trying to figure out which part of it is actually broken. And then you'll realize that you should in fact do yourself a favor, which is build a little bit and test it to make sure that the piece that you added does in fact work the way that you thought it should. Or the piece that you added, as the way that it interacts with the model, actually provides additional education to your intuition so that you better understand the way that the model works. There are lots of times when I interact with a model and I add something and it produces something that I completely don't expect. And either the model's wrong, my assumptions are wrong, because reality can't be as bizarre as what the model tells me is likely to evolve based upon the things that I told it. So it's really good to say, all right, I'm adding this, and this is what I expect to happen. You then run the model and say, all right, does it perform the way I expected? Do I need to teach it something, or is it trying to teach me something? And I continue cycling through this sequence on and on and on until I get the model to a point where it does in fact represent the situation or the context or the thing that I am trying to develop a better understanding of. So let's stop here, and I'll continue elaborating on this some more in the next video. Take care.